Hi, I'm Chris,
And I'm Priscilla.
and our project is the facial emotion recognition project. I'll just briefly be going over our code, but only the important parts for this class. So, we started with an FER 2013 data set, which we found on Kaggle, and this contains these emotions you can see here in the folders. But we did focus on only angry, happy, neutral, sad, and surprised for this project. To prepare the data in pre-process.py, we converted all the images to grayscale, as you can see here, and then resized them to 48 by 48 to normalize the pixel values, and then split into training and testing per usual. And then for the actual model and train model.py, we built a CNN neural network with three convolutional layers, each followed by batch normalization and max pooling to extract the facial features that we need for a model. And then we used a ReLU activation for nonlinearity and a softmax output layer for classification. And originally our accuracy wasn't too great, so to enhance this, we fine-tuned hyperparameters like the number of filters, learning rate, and dropout rate. And we lastly also implemented data augmentation techniques such as flipping and rotating images to help the model generalize a little better. And then down here, our training process involved the atom optimizer and the cross entropy as the loss function. And we found out that 20 epochs was about good for our training because going over than that, our accuracy took a bit of a hit. Okay, so now I'm just going to be demonstrating how our project works. So in order to start it, we just run the back end like that and then run the front end. And it'll give us this link that you can just go to on your computer to start it up. Um, just go here. So this is what the front end looks like, and I'll just be demonstrating the different emotions it can recognize. So I'll be starting with neutral. Okay, and then I'll just do happy and then sad.
Alrighty, and now I will demonstrate a couple of the other emotions, specifically surprise and angry. So we'll do surprise first. And finally, we will demonstrate the angry emotion. Um, and we'll omit the I hang out emotion just because it's not a common emotional response. So in order to visualize all of our data and results, we were able to create a confusion matrix, a confidence distribution, and a training history plot. So with our confusion matrix, you can see a very strong correlation in all of the diagonals, which shows that both the actual and predicted emotion labels tended to very accurately measure up, especially with happiness being the most strongly accurate emotion of all of them. There was some confusion between emotions such as neutral and sad, which makes perfect sense because some of those features start to kind of collide with each other in terms of how similar or different they are. But otherwise, there was a stronger correlation. However, because of the data set that we were using, there was very specific emotions that were displayed and without much variety in the actual features themselves. So because of how homogeneous the data set was, there was either a very low or a very high confidence in that prediction for the emotion being accurate. So that's why we have this bimodal density of confidence between 0 or 1, as opposed to a confidence distribution of anywhere in between 100% and 0%. And we can also see this overfitting of data in our training history, where we plotted our model accuracy and our model loss over different epochs. And this also has to do with the homogeneousness of the data set itself, where a lot of the cropped faces in the data set were only displaying one emotion as opposed to something in between, and causing our model to be too complex for the very simplistic data set that we were utilizing. So that concludes our project, and thank you very much for tuning in.